All right, this is lesson number 12. In the previous lesson, we talked about how to graph linear inequalities, a single one. And now we are going to solve a system of linear inequalities by graphing. So this time we will have two lines to graph instead of just one. So the solution to a system of linear inequalities in two variables graphically is the region on the graph that makes both inequalities true. So basically what we're going to do is we are going to graph each one of these, and then we can determine which region makes both of these true by testing a point, shading that region of that particular line, and then the overlap between the shaded portions of each graph is the solution to this system of equations. So let's do an example. Both of these equations are already in the form y equals mx plus b. I see that the first one has less than, so that one's going to be a dotted line. And if I graph y is less than 3x minus 2, I have a y-intercept of negative 2. So that would be here. And I have a slope of 3. So I have something like this. And remember, I have a dotted line. So this will look something like this. It's dotted since I cannot equal the points on this line. All right, and then which of the sides of this line should I graph? Well, I'm going to test my favorite point, 0, 0, and see if the point 0, 0 makes this inequality true. So plug in 0, 0. This gives me 0 is less than 0 minus 2, or 0 is less than negative 2, which is not true. So I know that the point 0, 0 is not in my shaded region. So I am going to shade this portion. So this portion of the graph makes the first inequality true. Next, I need to graph the second inequality. That is y is less than or equal to negative x plus 5. So again, I'm just going to graph it. This one's going to be a solid line since it's less than or equal to. My y-intercept is 5. 1, 2, 3, 4, 5. And my slope is negative 1. So my graph will look something like this. Solid line. And now I need to determine which side of this line makes my inequality true. I'm going to plug in 0, 0. You can plug in any point here. It's just that 0, 0 is pretty easy. So I get 0 is less than or equal to 5, which is true. 0 is less than or equal to 5. So that means that on this inequality, the point 0, 0 is included, which makes this the right portion of this inequality, the correct portion of the inequality. So what that means is that the overlap between these two portions is what makes the system of inequalities true. So that means that all of this up in here, including this line, but not including this line, makes our system true. So this is how we solve systems of linear inequalities by graphing. We graph the first one, see which side of it makes the inequality true. We graph the second one, see which side of it makes that inequality true, and then we find their overlap. And that overlap is what makes this system true. So all of these numbers in this green shaded region make this system of linear inequalities true. They are our solutions. All right, let's do another example. Find the solution graphically to the system of linear inequalities. Well, I see first of all that neither one of these equations are in my form y equals mx plus b, so I need to change that a little bit. So this first one is negative 2x plus y is greater than negative 4. So negative 2x plus y is greater than negative 4. To get it into my form y equals mx plus b, I'm going to add 2x to both sides, which gives me y is greater than 2x minus 4. So my negative 4 is my y-intercept. That is right here. And my slope is 2. Here I'm going to have a dotted line since I am strictly greater than. The solutions on the line do not make this inequality true. So I have a slope of 2. So I have this line, it's dotted. And which side do I need to shade on this one? Let's plug in a different point besides 0, 0. So maybe let's plug in 1, 1, just to change it up a little bit. If I plug in the point 1, 1, I get 1 is greater than 2 minus 4, or 1 is greater than negative 2, which is true. So I know that the point 1, 1 is included in my solution set. So I shade everything on the side with 1, 1. Excluding our actual line. That's the first one. And then if I look at the second one, we have y plus 8 is less than 2x. And again, I want the y on one side, so I'm going to subtract 8 from both sides to get y is less than 2x minus 8. So my negative 8 is my y-intercept. And this 2 is my slope. So I have my y-intercept here. And I have a slope of 2. These two lines are parallel to each other, notice, because they have the same slope. So these are parallel to each other. All right, and we want to see which side of this graph makes the inequality true. So I'm going to plug in 1, 1 again. Why not? Again, you can plug in any point here, any point that you want. So if I plug in 1, 1, I get 1 is less than negative 8, which is not true. So the point, the portion of the graph with 1, 1 is not included in this inequality, which makes this side the inequality. But look at that, there is no overlap between these two portions of the graph. And because they are parallel, there will never be any overlap. So that means that there is no solution to this system. No solution to this system. Parallel lines have so much in common. It's really a shame that they will never meet. All right, so this is an example of a system of inequalities within a solution. So yeah, that's it for today. Hopefully you learned a little bit about how to solve systems by graphing. And have a wonderful day. I will see you on Wednesday.